All right, so I started with the question 2x squared plus 11x plus 5 over x squared minus 25. And this is my work. So I want you to decide, I've made a mistake somewhere, or multiple mistakes in places. I want you to decide what my mistake was, and I want you to show me the correct work on the right, okay? If you're watching the video, pause the video, try it out, and then we'll take it up. Okay, so what was my big mistake that I did here? Raul? Okay, so no canceling. I did the math crime, and I know I saw people do this on the quiz. I would like a perfect test where nobody does this math crime. I mean, that doesn't mean everyone has to get 100, but I don't want anybody to be the person in this class that does this math crime. That's why I wanted to talk about this. So I'm canceling / reducing when I have pluses and minuses in between things. I do not want to do that. What is the proper route? Charlotte? Okay, so what did you get?
X plus 5 and 2x plus 1.
Good. So hard trinomial factoring on top there. You were looking for two things that multiplied to 10 and added to 11. Be 10 and 1. Split the middle term, do groups, and so on. Okay.
And then on the bottom, I did difference of squares, so I got x plus 5 and x minus 5.
Great. Difference of squares. Okay, so that would be the first step. That's what I should have done. Where to from here? Earl?
Cancel the x plus 5.
Okay. And I'm left with 2x plus 1, x minus 5. Anything else? You sure? What do I always have to have with questions like this as part of my final answer? Jack?
The restrictions.
Okay, so what should I have had? So I missed that over here as well, right?
Yeah, so it's plus minus 5. And then, yeah, that's it.
Yep, so we get negative 5 from this and positive 5 from this. Perfect. Okay. Without doing any work, like, we know that this was incorrect. Hopefully we all looked at this and we were like, that's the math crime that I'm not supposed to do. But without doing any work, how could I definitively prove to someone that this is not equal to this? What would I show them to prove that without showing the actual, like, factoring work? In other words, how could I prove that these two expressions are not equivalent? Jack? Plug what into both?
Like any x value.
Okay, so choose an x value.
7.
Sure, plug it into the top, plug it into the bottom, and that would be like a definitive proof that you can show somebody to say, like, these are not equivalent expressions. Raul, what do I not want to choose to plug in for x here?
The restriction. You can't plug them in or it's going to be in here.
Yeah, so this is one little thing. Raul just so happened to, when he was checking his quiz, he chose a restriction of one of his questions to plug in, and he kept getting error because that's not a permissible x value. So if I were to choose positive or negative 5 to try and check my answer here, I actually would have gotten an error because I would have made the denominator 0, and then in my calculator it tells me math error. So I cannot choose a restriction to plug in to check my answer. So that's one thing that we didn't mention when we were talking about equivalent expressions. So don't choose a restriction, choose something else. Okay, so let's get into some addition and subtraction stuff. So when I'm adding and subtracting fractions, what's the rule? I need what? Raul? I need a common denominator. Now, before I find common denominators, I actually am just going to check each individual fraction here and see if anything can be reduced, because that's going to help simplify things a little bit for me. So can either of these fractions be reduced individually, like with a top and bottom, just up and down? No. I also, so big math crime that I see in this unit as well is similar to what some people did on the quiz, which was cross-canceling when there was division in between. There's also no cross-canceling like this when there's addition in between. I can only cross-cancel when there's multiplication in between. So I don't want to do any cross-canceling. So common denominator between 3y and 6x, what would I do? Charlotte? Okay, and then I also need the variables to be similar. So Raul, what would I need to do for that part?
The right side you like multiply up and down by y,
Okay,
and then the left side you multiply by 2x.
okay, perfect. So common denominator between the numbers is 6, but one side has an x and one side has a y, and they each need that variable on the opposite side. So I need an xy on each side. So we're going to get 4x squared over 6xy plus y squared over 6xy. And then this is done when this is merged into a single fraction. So we're just going to merge this together. Keep the denominator, add the numerators. Restrictions. I need a restriction for any variable that's in the denominator. So I'll need one for x and I'll need one for y. Alan? 0 for both. If either of these are 0, they're all being multiplied, so it will just make the whole denominator 0 when they get multiplied. Okay, can I cancel an x and then cancel a y like this? Charlotte, no? Why? There's an addition, so we stop, right? We can't do that? Okay. So I'm going to keep testing you with that math crime so that nobody in this class does this on the test, okay? Okay. So next one. Any questions on that one before we go forward first? Okay, so next one. First thing I'm going to ask myself, can either of these fractions be reduced just as I look at the individual fraction itself? No cross-canceling or anything like that. Charlotte?
I just have a question about the last.
Yeah, sure.
Would you add the top together and just do 4x squared y squared, or would you keep them separate?
So does someone want to answer that question? What do you guys think? Raul?
It's like 4x, like you have to put like a plus because the whole thing is an addition, while if there's no plus, it will be a multiplication.
So if we were to change that, then it becomes a different operation. Also, we can only add variables that are alike, right? We can't add an x squared and a y squared. It'd have to be like an x squared and an x squared. Okay, so next one, can we cancel or reduce like anything in these individual fractions here before we start? Alan? Okay, so see how we have a common x on the right over here? I'm going to take that out before we start. It will just simplify the question a little bit. So let's take out an x. We're left with 5x over 6y, or sorry, oh yeah, I'm just writing it wrong. 5x over 6y minus 2x over 5. That's going to make me finding a common denominator easier. It will also mean that I don't have to like common factor and reduce at the end. If I had forgotten to do that, I would have had to common factor and reduce at the end. However, this x is still a restriction, so we might want to just start a restrictions list before we move forward here. 5 times x, what would cause that to be 0? Raul?
0.
0.
So technically, like restrictions start from like the very beginning to the very end.
Yeah.
So you restrict the whole entire thing.
Anything that was ever once in a denominator must have a restriction. That's the general rule. Okay, how about y? What's the restriction if we have 6 times y? Charlotte?
0.
Also 0. Okay, so now that we have that squared away, common denominator between 5 and 6y, what would we do? Maybe someone that hasn't answered yet. Common denominator between 5 and 6y. Nick?
For the 5x over 6y, you just do 5. And then for the 2x over 5, you have to do 6y.
Okay, so multiply this side by 5. and multiply this side by 6y. So common denominator would be 30y for this. Okay, so we're going to get 25 over 30y minus 12xy over 30y. And then we'll put these together in a single fraction. So 25x minus 12xy over 30y. This will be part of our final answer. And because factored form is simplest form, when we deal with questions like this, we always want to double check to see if there's any, like if we have multiple terms being added or subtracted, we want to double check to see if there's any like common factors that we can take out. It also will help protect us, like if we had forgotten to do this at the beginning, if we make sure we common factor at the end, then it will make sure that we reduce anything that needs to be further reduced. So are there any common factors here? Is there anything common between these two terms? Alan? Just an x, I think, right? They both have an x, so just take that out. And it doesn't really help us do any reducing here, but if we had happened to forget to do this at the beginning, it would have helped us do some reducing there. So it's always just a good thing to do. And also we talked about how factored form is always simplest form, so for simplifying, we want to express everything in like factored and common factored form where possible.
I have a quick question.
Yeah.
So, before like, no, not that way. If it was like 25x minus 12x, how would you answer it? There's no y.
I would put that together and I would just say 13x.
Oh,
Yeah.
so the x is
No, they wouldn't cancel. Any other questions on these? Okay, so we're going to apply something similar to more complex things with multiple terms and things like that. So these are your steps. Adding and subtracting is like a little bit more complex than your multiplying and dividing, but same kind of fraction principles apply and stuff like that. So for every single type of question, no matter if it's multiplication, division, addition, and subtraction, we will always start by factoring and common factoring everything we possibly can. So all numerators, all denominators, get it in factored form. Same thing for multiplication and division. Before we start canceling or doing anything, we will write restrictions. I would also maybe add in like a little tiny step here, which is check to see if anything can be canceled in the individual fractions like we did here. Because if you can do that, it makes your life like 10 times easier. So maybe just check for canceling in between these two steps. In individual fractions. Do you guys know what I mean by individual fractions? So like no cross canceling or anything like that, just like canceling in its own fraction, a top with a bottom. Okay, that a lot of times is not possible, but on the odd occasion where it is, you will be dealing, if you don't do that step, you're going to be dealing with things that you probably don't even know how to factor after that. So always check for that little extra thing there. Check for canceling in individual fractions, and then you can move forward. So with addition and subtraction, we need to find that common denominator. We'll have to multiply each side by what the other side has and by what each side is missing. We will merge them together as a single fraction. When we do this, we have to expand and simplify the numerators, and then gather all the like terms, and then check to see if the numerator can be fully, like even more factored, like kind of like we did here, right? We checked for more common factors or any factoring or anything like that. If not, you're done. If so, factor, and then see if you can cancel any further. So let's do a question together. So as always, we will factor and common factor everything we possibly can. not too much factoring that can be done with each 3 of these, but we can factor this. So we're going to factor by finding 2 things that multiply to 8 and add to 6. What would that be? Okay, 4 and 2. Also, I like to just bracket up these terms just to remind myself like these are groupings. So I would just put brackets around all those binomials. And we have, as we found, x plus 2, x plus 4 adds to 6, multiplies to 8, and it's easy factoring, so we put them right in the brackets, right? Okay, so we factored and common factored. What's the next step? What did the steps say? Before that. Okay. Restrictions? And Charlotte? Okay, so this one is -2, and this one is -4. Okay, Raul, what was that next little caveat step that we added in there? Okay, so in this one, x minus 2 over x plus 2, can I cancel anything? No? How about this one? Can I cancel anything? Are there any common brackets here? I don't think so. Okay, so move to the next. What's the next step? When we're adding fractions, we must have a common denominator. So they both have an x plus 2, but this one's missing what this side has, which is an x plus 4. So we're going to multiply that into the left side there. So this side needs an x plus 4 to get a common denominator. I must multiply that on bottom and also on top. Okay, so we're going to merge this together. You keep the denominator and just sort of like add your numerators together like so. So keep the denominator, put the numerators together. Okay, this is a little tricky. If the entire top has brackets that are all being multiplied together, I can cancel at this point. But that's not true here, because I have a multiplication of 2 brackets here and here, but then I'm adding a bracket on the end. So there's no canceling at this point. I understand, like we talked about how if there's multiplication in between, we can cancel. So I understand there's going to be, don't write this, but there's going to be some temptation to cancel those x plus 4s. However, I can only do this if I didn't have this plus here. If this was all being multiplied, I would be good to do that. But because I have that plus in between certain terms, it's like I'm canceling out an x plus 4 from this piece, but not from this piece, which we know we're not allowed to do, right? We can't cancel certain pieces out of certain parts, but not out of other parts. Okay, so no canceling yet. This is a huge, huge thing that I see people do in this unit. So you gotta kind of get this down as to like when you can start to cancel and when you can't. So no canceling yet because of the plus x minus x plus 10 on top. Okay, and the big part is because we're adding that. So instead, we will continue to follow the steps. We need to expand and simplify the numerator. So I'm actually going to take steps to FOIL this. And this is really just like a plus 1. So technically, I guess we're multiplying by positive 1, but we can just drop those brackets there. Okay, so I'm going to get x squared plus, minus 2x. Okay, first outside, inside last, plus 4x minus 8 plus x plus 10. Do not FOIL the denominator. There's no need to do that because this is already in perfect factored form, and we know perfect factored form is fully simplified. This one was not in perfect factored form because I had that plus x plus 10 on the end. So leave the denominator, you're going to FOIL and expand the numerator and then gather any like terms. So we'll have x squared, we have 3x on top, and minus plus 2 on the bottom, or sorry, plus 2 at the end. Okay, we have two options to finish this, and we have to kind of make the call. So the question is, can we factor? If no, we're done. If that's a yes, we need to continue. So are there any two things, this is a trinomial now, so are there any two things that multiply to 2 and add to positive 3? Jack?
2 and 1.
Okay, so if so, we will continue and we will factor. Sometimes it will be a no, and we'll just finish it there. Common factoring also counts as factoring as well. So if you can common factor, you want to make sure you do that. Okay, final thing, I want to check to see if everything is simplified that can be simplified. Alan? Yes, so now that there's all multiplication happening on top, see how the brackets are all being multiplied? There's no like extra terms being added or subtracted. I can cancel out full groupings of x plus 2. And I'm left with x plus 1 over x plus 4, and the restrictions that we wrote above, which were negative 4 and negative 2. Okay, so a couple more steps for addition and subtraction. The big things here are like this step where we make sure that we don't start canceling yet because of the plus, or sometimes maybe there's a minus there. We have to expand and simplify the numerator and then check to see if we can kind of refactor. So this should be the simplest form of what we started with above. Any questions on this? Okay, let's try a couple more. This one's a subtraction one. So we just did an addition one. We'll see what's different between addition and subtraction here. I'm just going to make this guy a little bit smaller. Okay, so first step, what do I do? This goes for all questions. What's the very first step that we always have to do first? Raul? Factor and common factor everything you possibly can. I also like to just bracket up all these binomials that are by themselves. So x plus 9, not too much I can do with that. Can we factor the bottom left? Multiplies to negative 48 adds to 2. Are there any numbers that work for that? Multiplies to negative 48 adds to 2. 8 and negative 6 should work, and it's easy factoring. X squared has a coefficient of 1. So positive 8 and negative 6 should work. Okay, and then I think we can try for this trinomial down at the bottom right as well. So multiplies to negative 30 adds to negative 1. Negative 6 and positive 5 should work. So again, easy factoring right into the brackets with the x's. Okay, so we factored and common factored everything. Next step. Restrictions, so start a list. X cannot equal
6,
and negative 5. Good. So just the bottoms, the tops are okay. The tops can be 0, that's fine. Okay, little tiny thing that we want to check. Can we factor, or sorry, can we cancel anything in those individual fractions? Do we see any common brackets on the bottoms or tops of these? Okay, so that would be a no, but make sure you double check that. Okay, so we've checked those. In order to subtract fractions, we need a common denominator. So each thing needs what the other side has, right? Alan, what would you do?
On the left side, on top of multiple, not x plus 5. On the right, plus 1 multiple, with the 8.
Okay, perfect. So I need an x plus 5 on this side, because that's what this side has that this side doesn't. they both have the x minus 6, so that's good. And then this side has an x plus 8, which the right side is going to need. So let me actually move this over a tiny bit. So I need an x plus 8, and whatever I do to the bottom, I must also do to the top.
Those are multiplied, right?
Those are multiplied. Okay, merge into one fraction. Keep the denominator, and we're going to put those numerators together. Sometimes I see people that will start to multiply these denominators together, like they'll put squared on all of these when they put them together because they think that there's two of them, so they have to write it twice. That would be like another common mistake that I see in this unit. We only need to write it once because we're writing, it's basically just this whole thing over this common denominator that we found, right? When I do 2 over 4 plus 3 over 4, I keep the 4 and I just add the 3 and 2, right? I get 5 over 4. So same kind of idea. Okay, so this is the part where we need to resist the temptation to start canceling like this. Why can't I cancel yet in this scenario? What's the problem with this? Raul? We have a big subtraction in between all of those. If that wasn't there and it was all brackets being multiplied, we would be good to go. It is there though, so no canceling yet. What do we have to do instead? Alan? Okay, so FOIL the top. The big difference between addition and subtraction is that when I FOIL this second bracket, I'm actually going to leave this in brackets because the negative will apply to every single term in that expansion. So that's a big difference between addition and subtraction. So we're getting x squared plus 9x plus 5x plus 45 minus, and then I'm going to keep brackets for this one. Again, key difference between addition and subtraction. And then I'm going to get x squared plus 8x minus 9x minus 72. Keep the denominator. It's already perfectly factored. There's no need for us to FOIL that. Raul?
Is it wrong if I put a bracket on the first one at the top?
You could, but then you're just going to drop it in the next step because there's nothing for you to have to bring in there. Okay? And again, the reason why I kept this bracket here, you might even want to highlight this in your notes if you have something that you can highlight with. The reason why I kept this is because this negative has to be brought into each term when I expand. So this negative gets brought into everything. Okay? This is a key step for the difference between addition and subtraction. If that was a plus there, I could just drop the bracket because it doesn't change any of the signs, but the negative being there changes the sign of everything in that second part. Okay, so I'm just going to add the 5 and the 9 together. That will be 14. And then we're going to have negative x squared minus 8x plus 9x plus 72. After you found the common denominator, it pretty much just stays the same as you continue working on it. Notice that I haven't touched the denominator since I found it above as the common denominator. Let me move this down. Okay, so you're going to gather all those terms on top. So x squared minus x squared, those are gone. Right? Those are just opposites. They'll cancel each other. Gather all the x's together. So I think we have 15x on top now. 14, and then this is just 1x right here. And then 45 and 72, 117. Thank you. And same denominator as before. Okay, now I'm going to ask myself the question, can I factor or common factor this at all? I don't think we can factor because it's not a trinomial. But is there anything common between 15x and 117? Do they share any common numbers that could be taken out? They share 3. So If we take out 3, we'll be left with 5x, and remind me, what is 117 divided by 3? Is it 39? Okay, so that was a yes. So we want to do it if we can. And final step, check to see if there's any common groupings now that can be canceled. Any top piece with a bottom piece, is there anything? I would have to have another 5x plus 39 in order to really do much with that, right? So that's going to be our final answer, along with, of course, our restrictions from above, which were -5, -8, and 6. So that's always a part of the final answer as well. As long as you have them somewhere, just box them up so I can see them easily. As long as they're somewhere, that's fine. Okay, questions on this? Can I clarify anything? I know these ones are a bit longer. We're all okay? Okay, last one. So factor and common factor everything you possibly can. That's the first step of every single one of these types of questions, no matter what operation you're doing. So top left, what can I do there? Jack?
You can do 5x minus 6 times 5x plus 6.
Ah, okay, difference of squares there. So 5x minus 6, 5x plus 6. Good? Okay, bottom left, this is hard trinomial factoring. So I'm going to do this one quickly because I assume that people know how to factor these at this point. So this will be 6, -6, and 1. So I'm going to get 5x minus 6 and x plus 1. Okay, again, you guys need to know how to factor these for yourselves, but I'm just doing it a little bit faster because I assume that you guys know how to do like the A times C method and then do your groups or whatever method you've chosen to work on for long factoring. Okay, top right, what do we do here? Charlotte? Okay, difference of squares. And the last one, bottom right. Raul?
X plus 3 and x plus 1.
Okay, so multiplies to 3, adds to 4 would be 3 and 1. So easy factoring right into the brackets with those numbers, 3 and 1. Before we do anything, we are going to do restrictions so that we don't miss anything. So what would I put in my list? Alan? Super close. -1 and -3 I'm on board with. Raul, what would you change?
The 6 would be 6 over 5.
Yes, so because we have a 5 here, that's right over left and switch the sign, so 6 over 5. Okay, here's that little caveat step that we kind of added in there, which is look at the individual fractions and see if a top can be canceled with anything on the bottom. Jack, do you see something? Okay, this just made my life like 20 times easier. If I forget to do this, I make my life unnecessarily hard to the point where like I might not even be able to do the question. So that's an important little caveat step to do. Okay, so now that we've canceled those, we will go and we will find a common denominator. Each side needs what the other side has. So they both have the x plus 1, but the left side needs what the right side has. So the left side will need x plus 3 on top and bottom. Okay, merge this together in a single fraction, keep the denominator, and you're going to add those numerators together. Just kind of like smushing these together in one fraction. Okay, what is the big math crime that I do not want to do right now, that someone is probably going to do on their test, but you're going to make sure that it's not you, Jack?
Cross dividing, there's a minus.
Okay, There is a minus here, so no canceling at this point yet. Okay? Make sure it's not you that does this on the test. Ethan's going to make sure that it's Ryan, right? And not him. I'm just kidding, Ryan. You'll make sure that it's Charlotte, right? All right, so it's not going to be us, right? Okay. What do I do instead? Foil. Okay, good. So firsts, outsides, insides, lasts for each one. When it's subtraction, you keep brackets around this guy, okay? Because that subtraction has to go into everything in that expansion over there. Okay, so I'm going to do this quick. We get x squared plus 6x plus 15x plus 18 minus, and actually, when we expand this, notice that this is really just what we had here before, which is x squared minus 16. The reason why we took the step to factor it is just in case if we were able to cancel something in that step, then we could have canceled it. But really, this is just going to expand back into x squared minus 16, right? Because we'll get a positive 4x and a negative 4x. If you didn't recognize that, that's okay. You can still expand as usual. But I'm just going to write x squared minus 16 because we know that's the expansion of difference of squares there. Okay, still important to do that factoring step though, just in case you were able to maybe cancel before continuing. Alan? 5? Oh yeah, thank you. Yep, 5x squared. Okay, bring that negative into the second bracket. I'm also going to just gather those together as I do this. So 21x. And we're almost there, last couple steps here. We're going to gather all those like terms now. So 5x squared minus x squared. That will give us 4x squared. I've got a 21x, and I've got a 34. Okay, I would need to be asking myself, can I factor or common factor anything at this point? So I would need, in order to factor, this is a hard trinomial, I would need something that multiplies to b and then adds to a times c, which is 136, is that right? Okay. So is this possible? That is the question. This one's kind of difficult because 136 is a pretty big number. So you could actually just go through all the things that add to positive 21. Like you could do 20 and 1, which adds to 21, but that obviously doesn't multiply to 136. 19 and 2, that obviously does not multiply by 1 to 136. 18 and 3, and so on. So if you just went through those combinations, I don't think we will find anything here. Probably like we would get closer to maybe like two numbers that are like similar to one another, like close, like 9 and 11. That gives us 99. It's still, or sorry, 9 and 12, I guess, would add to 21. So that still doesn't get up to 136. We could try like 13 and 8 maybe, but again, all of those aren't going to work. So this is going to be a no. And that means that we can actually just leave it. We'll just leave it like this. And these are our restrictions. Okay, so we don't have to do any final steps of like factoring or common factoring or anything like that here. Okay, you might want to write yourself a note. Keep the brackets here. The negative must go into each term. Okay, so that is a really key thing for subtraction, that when we FOIL in that second half, that we keep those brackets and the negative goes into each term. So you might, again, for your future forgettable self, you might want to write yourself a note. Keep the brackets here, the negative must go into each term for all subtraction questions. Okay, we're going to take the rest of the time today and we're going to start working on practicing this. I would suggest we are going to have 2 blocks of review next time, so you could take a little bit of time at the beginning of that class to finish this, but I would suggest you try to get the majority of it done before the next class. That way you can kind of start and review and start fresh that class after having completed everything. I know, guys, that these are there's a lot of questions and it can be a little bit tedious, but practice really